I set to solve a rational equation to answer each of these applications. Caleb's average driving speed is 12 kilometers per hour slower than Ling's. In the same length of time it takes Caleb to drive 231 kilometers, Ling drives 297. What is Caleb's average speed? Okay, well, clearly this is a uniform motion. So I know rate times time is equal to distance. So it's easier for me to set up a table. Okay, so we have rate, time, and distance, and we're dealing with Caleb and Ling. Okay, so let's see what Caleb's average driving speed is 12 kilometers slower than Ling's. Okay, that means if I know what Ling's is, then I can subtract 12 from that to get Caleb's. The same length of time, so these are going to be the same, which means they're equal. And Caleb's distance is 231, Ling's is 297. Okay, so if rate times time equals distance, then time is equal to distance over rate. So for Caleb, the time is equal to the distance divided by the rate. For Ling, the time is 297, the distance divided by the rate. And I know these are the same, so I can set this up and say, well, these two are equal. So I have 231 divided by x minus 12 is equal to 297 divided by x. And cross multiply on this one. So that gives me 231x is equal to 297 times x minus 12. 231x is equal to 297x minus 3564. Subtract 297x from both sides. I get negative 66x is equal to negative 3564. When I divide, I get that x is equal to 54. Okay, so this tells me that Ling's speed is 54, and this is in kilometers, yeah, kph. But that's not what the question asked. It wants to know what is Caleb's speed. Well, Caleb speed is Ling minus 12, which is 54 minus 12, which gives us 42 kph. And that's the answer they're looking for. Okay, so let's go on to the next page. Can I find it somewhere in here? There it is. So let's see what we've got going on here. All right, so Carl is an experienced shipping clerk. He can fill an order in 6 hours. Tim's a new clerk and he needs 8 hours to complete the same job. How long would it take for both working together to fill this order? So this is clearly a work problem. So I have 1 over T1 plus 1 over T2 is equal to 1 over T for both. So I've got to know 2 out of the 3 and I solve for the third. All right, we'll call this one Carl and this one Tim, and this is both. Okay, so Carl takes 6 hours, so that gives me 1 over 6 10 takes 8 hours. And that's what I want to know is how long it will take them working together. Since it's a rational equation, I want to get rid of the fractions. So my LCD, let's see, 6 is equal to 2 times 3. 8 is equal to 2 times 2 times 2. And T is equal to T. So my least common denominator is 2 times 3 times 2 times 2 times T, which is 24T. So I'm going to multiply this entire thing by 24T. So that gives me 24 divided by 6, that gives me 4T. 24 divided by 8, that gives me 3T, is equal to 24. 7T is 24. When I divide by 7, I get that T is equal to 24 over 7, which I would convert to a decimal, and I would say that's 3.43 hours. Okay, a birdseed mix is produced with a 5:8 ratio of sunflower seeds to corn kernel by weight. In a bag that is 10 pounds of birdseed, how much of each ingredient is included? So I want to compare an ingredient to the total. Well, I can use either one because I know 5 is how many pounds of sunflower seeds, and 8 is how many pounds of corn kernel. But the total is equal to 5 plus 8. So if I do sunflower seeds, then I know 5 pounds of sunflower seeds in the total of 13, and I want to know how many pounds there would be of sunflowers out of a total of 10 pounds. So now I just cross multiply, and I get 13x is equal to 50. When I divide by 15, excuse me, I get x is equal to 50 divided, let's call that 3.8 pounds. So how much of each ingredient? So sunflower seeds is 3.8 pounds. Now there are a couple of ways that I can find the corn kernels. I can set up the same ratio instead of 5 over 13, 8 over 13. But if I know the 10 pounds is total, so then the corn kernels is 10 minus 3.8, which is 6.2 pounds. Don't make it harder than it is. Oh, write each of these in radical form, simplify, and no negative exponents. Okay, so if I have x to the negative 2/3, y to the 5/3, I can write this. I'm going to put it in radical form. There are a lot of different ways that you can do this. Okay, but this becomes x to the negative 2, y to the 5th to the 1/3. Which becomes the cube root of x to the negative 2 y to the 5th. Okay, so I'm getting closer, but there are two things I have to take care of. This can't be negative, so I know how to take care of that. And here, my exponent is larger than my index. So clearly I can pull something out. All right, so I'm going to kind of take care of these in the same step. So this becomes the cube root now of y to the 5th divided by x to the 2nd. Okay, so that's taken care of. Well, how many times does 3 go into 5? 1. So I can pull out a y, and then I'm left with the cube root. I have 2 y's left over, and I can't pull any of my x's out. Okay, no negative exponents, yay. So I've got to put it in radical form and then simplify. So here, since my exponent is 1/2, this is the same as the square root of 32x to the 2nd y to the 5th. Okay, well, I know 32 is 2 to the 5th times x to the 2nd times y to the 5th. So I'm going to be able to pull something out. So let's see. 2 goes into 5 because my index is 2. 2 goes into 5 2 times. So I've got a 2 to the 2nd out here, and I have 1 left over. The square root of x to the 2nd is x. And my y, 2 goes into 5 2 times, and I have 1 left over. So just to make it a little more clear, this becomes 4x y to the 2nd times the square root of 2y. Okay, let's see what I have to do on this one. All right. Well, I know I've got x's here and I've got y's here, so I can turn those into a single base with an exponent by adding these exponents. So this becomes x to the 3/2 plus 5/2, y to the negative 5/2 plus 2. Okay, 3/2 plus 5/2 gives me 8/2. So x to the 8/2. Let's see. 2 becomes 4 over 2. So negative 5 plus 4 gives me y to the negative 1/2. Okay, 8 over 2 gives me x to the 4th. And y to the negative 1/2 becomes 1 over y to the 1/2. So now I've got to put it in radical form. So this just becomes x to the 4th divided by the square root of y. Okay, on this one, let's see what we can do with this. I'm going to write it in its radical form. So this becomes the cube root of negative 32 x to the 4th y to the 9th. Okay, so this is the cube root of -2 to the 5th. We did that up here. X to the 4th, y to the 9th. Okay, so I can pull out a -2 to the 3rd. So this becomes -2 to the 3rd. And left I have -2 to the 2nd. 3 goes into 4 one time, and I have 1x left over. 3 goes into 9 three times, and I have nothing left over. So -2 to the 3rd. Oh, I'm sorry. I just pull out a -2. So that gives me -2 xy to the 3rd times the cube root. -2 squared is 4x. Okay. Number 11. Let's see what I can do with these. These I want to write with a rational exponent and simplify. Okay, well, we know that this just means x to the 3/4, and there's nothing I can do with that. This means 4x to the 7th to the 1/2, which is 4 to the 1/2, x to the 7/2 when I multiply those exponents. Well, 4 to the 1/2 is 2, and I'm left with x to the 7/2. And I'm done. Yay. Okay, radical equations. I hope I have enough room for these. I'm going to pretend that I do. Okay, solve the following radical equations. Remember the process. Isolate the radical. Take it both sides to the power of the index. And I always have to go back and check my answer. Okay, so if I have x equals the square root of 5x minus 6, I'm going to go ahead and take both to the second power. So that gives me x squared is equal to 5x minus 6. Okay, so I know how to do this. All right, so it's a quadratic. I set it equal to 0. This becomes x squared minus 5x plus 6 is equal to 0. This is easily factorable into x minus 2, x minus 3 equals 0. So x equals 2 or x equals 3. Okay, now it's apparent to me that if I plug in a 2 or a 3, that they will check. But I'm going to check them anyway, just because I can. All right, so I'm going to check x equals 2. So I want to know if 2 is equal to the square root of 2 times 5 minus 6. 2 is the square root of 4, and that checks. So now I'm going to check x equals 3. I want to know if 3 is equal to the square root of 5 times 3 minus 6. 3 is equal to the square root of 15 minus 6 is 9. So they both check. All right, so I'm going to Put my little line down the middle here. All right, so what do I have to do here? This is the x is not isolate or the radical, so I'm going to have to add 5 to both sides. So that gives me x plus 5 is equal to the square root of 1 minus x. Now I can square both sides. So x plus 5 squared gives me x squared plus 10x plus 25 is equal to 1 minus x. Okay, so let's set it equal to 0 by subtracting 1 and adding x. Add x, subtract 1. So that gives me x squared plus 11x plus 24 is equal to 0. X plus 3, x plus 8 is equal to 0. So if I follow up here, this tells me that x equals negative 3 and x equals negative 8. So now I just have to check it. Oh, and these are negatives. No, the answer, okay, I did it right. All right, so let's check. Okay, so let's check x equals negative 3. So I want to know, is negative 3 equal to negative 5 plus the square root of 1 minus negative 3? So is negative 3 equal to negative 5 plus the square root of 4? Negative 3 equals negative 5 plus 2. So that checks. So this is a solution. So let's check x equals 8. Okay, so I want to know if negative 8 is equal to negative 5 plus the square root of 1 minus negative 8. So negative 8 is equal to negative 5 plus the square root of 9 is 3. They are not equal. So this is an extraneous solution. Okay, so now I've got a cube root. All right, so it's the same thing. I'm going to isolate the radical and then take the whole thing to the power of the index. So I am going to subtract 3 from both sides. And that gives me the cube root of 2x plus 1 is equal to negative 2. Now, since this is an odd index, it can be positive or negative. So you can't just say no. If it was square root, you could just say right here, no, this isn't possible. So what I'm going to do is I'm going to take each of these to the power of 3. So that gives me 2x plus 1 is equal to negative 8. 2x is negative 9, so x is negative 9 halves. Now, since it's a cube root, it can be positive or negative. But just to stay in the habit, I'm going to go ahead and check it. So let's check. So I want to know if 3 plus the cube root of negative 9 halves times 2 plus 1 is equal to 1. So this is 3 plus the cube root of negative 9 plus 1. So this is 3 plus the cube root of negative 8 is 1. 3 plus negative 2 is 1, so it checks, and it is a valid solution. Okay, so on this last one here, let's see what I can do with this. All right, 3x to the 5 halves plus 4 equals 100. I'm going to do it quickly so the video isn't so long. All right, I'm going to get the x to the 5 halves by itself. So the first step I'm going to do is subtract 4 from both sides. So this gives me 3x to the 5 halves is equal to 96. Divide by 3 and I get x to the 5 halves is equal to 32. So what I can do from here is I can take everything, the index is 2, so I'm going to take everything to the second power. So that gives me x to the 5th is equal to 32 to the second. Now the reason I did that is because I know 32 is x to the 5th. So this tells me that x to the 5th is equal to 2 to the 5th to the second. X to the 5th is equal to 2 to the 10th. So now if I take everything, I'm going to take it to the 1/5 power. So this gives me x is equal to 2 to the 10 over 5, which tells me that x is equal to 2 to the second, which is 4. Now, there may be a little bit easier way to do that, but that's okay. Now I changed videos here. I didn't realize how long I'd been talking.